Now that is a pretty big explosion. A cusplosion. How strong is Megumin's explosion? That one very simple question is what we will be answering, and less simply, we will answer it in exact yield measuring in kilotons of TNT. Specifically, we will look at the magnificent explosion spell that Megumin unleashes in one of my personal favorite scenes, which is the end of the Konosuba movie, where after Megumin resigns herself to give up the chase of the art of the explosion, Kazuma surprise upgrades that explosion and shows her that she can continue to be a deranged explosion casting fanatic that doesn't need to give up on her dreams for him. A truly emotional and climactic scene, which is why we proceed to ignore that because that's not what we're here for today. It's time for some brain damage and some big bang booms. Sorry about that. Got a little excited there. In order to properly determine the theoretical yield of Megumin's explosion spell, we must steel our nerves and become one with the FBI watch list. A few crucial pieces of information are given to us, namely, a scene showing Megumin's initial casting of the explosion, a wide, high atmospheric shot of the mushroom cloud and its all-important blast wave cascading across the surface of this wonderful world, and finally, a scene showing the trailing wind behind this blast wave flowing past Kazuma and Megumin. And of course, the rest of the movie, yeah, okay. This isn't much, but it is all we need to determine the exact blast yield of Megumin's magic-based explosion, whether that be the dynamite and ammonium nitrate fuel mixture used in mining, the TNT used in deadly ordinances, or a Minecraft faction server. From the popping of a balloon to a hypothetical nuclear Armageddon, explosions simply are a violent expansion that releases a bunch of energy in the form of a shockwave, sound, heat, and light, with the release of said energy resulting in air being compressed to create a super fast wavefront, in this case being a blast wave. And if every explosion creates some form of blast wave, then even though magic, and likewise explosion magic, does not actually exist, and no direct equivalent to an explosion spell cast by a fanatic demon mage has ever been measured, we can still apply the characteristics of all non-magical explosions by utilizing known approximations related to the ideal blast wave. Right here, as you can see, is a graph of said ideal blast wave, showing pressure relative to ambient pressure against time. This spike in pressure at the beginning, or the peak positive pressure, is created immediately upon detonation and decays rapidly as time passes, where then a lesser negative pressure wave follows it as it then decays again back to the normal ambient pressure. Alas, upon performing an intense examination, I have realized a terrible truth. There are no pressure sensors in Konosuba, and placing convenient pressure sensors into my computer screen didn't seem to be working either. Does our journey truly end here? Can we go no further? No, I refuse, because we do have a pressure sensor in the anime, just one we cannot see. Wind. Yes, wind and even our weather patterns are caused by a difference in pressure. So clearly there must be a way to relate the wind created from an explosion and the peak positive pressure of said explosion, which, despite my lack of any credentials, is a statement I can fairly confidently get behind. After scouring the depths of the internet, I finally rolled up on this paper from the University of Tennessee that not only gave me exactly what I needed by listing various equations related to pressure, wind speed, energy, and a shit ton more about explosions, but also made it much easier for me to find other reports on blast characteristics, including this JRC report to the EU and many other United States government websites. This then brings us to the method that will lead us to victory in the determination of the strength of Megumin's explosion magic. The plan is simple. Estimate the wind speed. Find peak positive pressure, determine the best theoretical model of explosion, estimate the distance away from the explosion, then find the yield of the explosion in tons of TNT, and step 6, profit. And that's just what I did. To find the wind speed, simply take a gander at this chart from weather.gov and compare that with visual clues from Konosuba. As you can see in the immediate aftermath of the blast wave, both Megumin and Kazuma's clothes readily flap in this gust of wind, and because of this, a Beaufort level 6 of 22 to 27 knots is appropriate, as it describes similar observations with heavy flags and the rigging of ships, but for the purposes of today, right in the middle or 25 knots is fine. This then brings us back to those equations from earlier, starting with this one, which I will not be reading. Basically though, it relates the wind speed behind the shockwave U to the peak positive pressure and ambient pressure with a constant representing the speed of sound. Therefore, if the ambient pressure in Konosuba is assumed to be 1 atmosphere or 1.013 bar, then it allows us to calculate the peak positive pressure from the estimated wind speed. But in order to get to the actually really fun stuff, further we must go. These smart people keep telling me about theoretical models of explosions and how they are represented by different equations of varying prerequisite conditions. After much deliberation, I settled on the Nukemap surface explosion model, represented by this equation, mainly because this hemispherical model represents an explosion that occurs on the surface, like the one released by Megumin. This matters as the reflection of the blast wave off the ground, as opposed to being in the air, greatly changes the rate of pressure drop-off as it occurs at farther distances. Speaking of which, we also need the distance away that our measurements with Megumin and Cosmo were taken, in this case represented as R, to calculate the relationship between peak pressure and the actual energy released by the explosion, because last I checked, it clearly matters how far away from an explosive you are. And if you don't believe me, we can do a challenge where you take a grenade, I stand about 2 miles away, and you pull the pin out and shove the grenade up your ass. Anyways, to get any kind of distance measurement, we need a point of reference of some kind, which fortunately is provided in this scene. Don't really see too much, me too, except for the beautiful shot as the clouds disappear over the horizon. The horizon curvature. If we assume the radius of the wonderful world of Konosuba is the same as the less wonderful world of Earth, then by measuring the angle of horizon drop-off, roughly equivalent to the zenith angle, and using these equations from the most reliable source, Wikipedia, we can obtain a rough estimate of the height and then the distance to the horizon in this frame, which is about 55 kilometers from a height of 250 meters. By taking into account the time it takes for the blast to reach Cosmo here, how far it travels in the wide-angle shot, and the right transition of terrain from stratovolcano mountains to rolling hills, this leads us to the amazing scientific conclusion that, they're standing about here-ish. Incredible. Using pixel measurements, we take the ratio between that and the total pixel measurement of the frame, and then use the wisdom of this random dead guy Pythagoras to calculate the distance away, which is about 4 kilometers. And so we go back to the equation here again and substitute the distance r with 4 kilometers and the peak pressure in bar. Doing some calculations and verifying the slightly odd units of the final results, it is now time to know the truth of what we have all been waiting for. In that moment of growth and intense emotion, Megumin's upgraded explosion blasted across the wonderful world of Konosuba with a yield of 22 kilotons of TNT, only slightly more than the second atomic bomb dropped at that specific moment in history that gets me demonetized. But that's a pretty terrible frame of reference anyway, in more ways than one. So to really visualize this raw power, we go to my favorite website, Nukemap. If there already weren't enough reasons not to go to Detroit, then today we have one more. In the event that Megumin were to cast explosion magic in the city center, the fireball completely engulfs multiple city blocks as glass and buildings miles away completely shatters, and untold devastation would unfold as massive swaths of the city catch fire. Of course, Megumin isn't actually the reason why that happened, because as you know, the demonic invasion of Earth started in Detroit last Tuesday. Therefore, with all that in mind, it is not weebs who should go to jail for their Megumin body pillows, but instead Megumin herself for violating international arms treaties with this clearly excessively large incendiary explosion that poses an unnecessary risk to surrounding civilians and innocent bystanders. Well, actually, I think this entire group probably has a few more reasons to go to prison anyways, so yeah, that does it for today. I got nothing else to say, so if you enjoyed this video, then I encourage you to, without delay, hit that subscribe button, and I will see you in the next video. Stay off that watch list, y'all.